Let's look at the definition of an odd integer. So let's let n be an integer. We say n is odd if there exists an integer k such that n is equal to 2 times k plus 1. So for instance, as you know, 7 is odd because 7 is equal to 2 times 3 plus 1. So this would be the value of k for this specific value. To write some more theorems that talk about properties of even and odd integers. Let's do this statement. Let's say let n be an integer. Let's make the claim if n is odd, then n squared plus 1 is even. So let's write the proof of this statement. Let n be an integer, and suppose n is odd. By definition, there exists r, which is an integer, such that, let's use p. There exists p and an integer, such that n is equal to 2 times p plus 1. Now, n squared plus 1 is equal to 2p plus 1 squared plus 1. And now we have to remember how to square something. So as a really quick side calculation, I'll FOIL it out over here. 4p squared plus 4p plus 1, which will be the same as 4p squared plus 4p plus 2. And also, that's equivalent to 2 times 2p squared plus 2p plus 1. We see that there exists an integer 2p squared plus 2p plus 1 such that n squared plus 1 is equal to 2 times 2p squared plus 2p plus 1. Thus, by definition of even, n squared plus 1 is even. So look at this proof and maybe copy it down or try rewriting it in your own words and see, if it flows for you, if it makes sense.